known as GAS. And today we are here to start with business statistics. I'm here to enlighten you more on business statistics and also to teach you some key terms when it comes to business statistics. And today we are going to start with classification of data. Classification of data, which is chapter 2 under business statistics. So now we move to the next stage of this topic. It says graphical representation. We move on to graphical representation. We move on to graphical representation. So now the information provided by a frequency distribution in a tabular form may be presented graphically. So under graphical representation, we have the histogram, we have the frequency polygon, and we have the cumulative frequency curve. So we have the histogram, we have the frequency polygon, and we have the cumulative frequency curve. So now, Jim Adesam or guy standing here is going to show you how all these three are done. So let's start with histogram. Let's start with histogram. We begin with histogram. We begin with histogram. It contains rectangles having bases on a horizontal axis, centers at the class marks, and lengths equal to class interval sizes. Areas proportional to class frequencies. So now there's a question here we are going to solve that is going to help us understand what we are talking about. So it says draw a histogram for the following data. It says class interval is of 10 to 19. 10 to 19, the data is being showed on your screen. 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. So this class intervals comes, then frequency is also beneath it. So the 10 to 19 is 2, 20 to 29 is 4, 30 to 39 is 6, 40 to 49 is 2, and 50 to 59 is 1. So now you arrange this in a table form, which is class interval will come, then you find its class bandwidth, and the frequency will also come. So this was what I was talking about. So now this question has been given, this data has been given, and we are asked to draw a histogram for the following data. So first of all, you have to draw your table. You have to draw your table having your class intervals, having your class boundary, and your frequency. So now let's draw a table. So we have our class interval, we have our class boundary, then we have our frequency. So now the class interval was given to be 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. So now it's up to us to find out what our class boundary. And as I said, how then do we find our class boundary? You will have to take the upper class limit, or now this is interval. So you take your first upper class interval, then you subtract this from your what? Your second lower class interval. So when we take the 19, we subtract this from what? 20, and it will be 1. The number you get, you divide that number by 2. So when we divide 1 by 2, we are getting 0.5. So now with the 0.5, you will subtract the 0.5 from your first lower class interval. You subtract the 0.5 from your first lower class interval, which is the 10. Into what take 0.5 free 10, ma obenya 9.5. Na watwerɛ ato ha fɛfɛɛfɛ. Wowie a, na saa 0.5 no, wode abɛka 19 no ho. Na ɛno nso, watwerɛ ato ha fɛfɛɛfɛ. Na wayɛ no saa ama wei nyinaa. You do the same thing for the rest. So now let's state our figures. Good. So now you can take your calculator and also input it and check if what we have done here or what I have done here is accurate. So now after doing this, you are given frequency. So now you come and state your frequency. And 1. Then you do this, come. You state it nicely here. Then this data is going to aid you draw the histogram. This data here is going to aid you draw the histogram. So now I'm cleaning the board so that I draw the histogram for you to have a look. But before that, if you don't have a graph book, go and get a graph book. So now we all know the x and y axis, right? So now we are drawing our histogram. This is a rough sketch for you to get how the thing will be done. So you can also go and get your graph book and also follow what I'm doing. So now here should be our frequency. Here should be where we are going to state our frequency. This is where we are going to state our frequency. And here, the bottom here is going to be where we are stating our class boundary. So this is where we will be stating our class boundaries. So we have our frequencies to be what? We have our frequencies so we have 1, 2, 3, 4. 5, and 6. So now we state our what? Our class boundaries. So we have 9.5, we have 19.5, we have 19.5, we have 2, we have 29.5, we have 39.5, we have 49.5, and we have what? 59.5. Have 59.5. So now what we do is that we match them. We match them. We match them. So 9.5 to 19.5 maps onto what? 2. So we match them. We match them nicely. We match them here nicely. Then also 19.5 to 29.5 maps onto what? 5. So it's a continuation of this. 19.5 to 29.5 maps onto 4. So you do that nicely here. This is just a rough sketch, as I said. You do that nicely here. Then 29.5 to 39.5 maps onto 6. So it's a continuation of it. Then you do that one to nicely. We move on to 39.5 to 49.5. That one is 2. That one is 2. So you trace it to 2. You trace it to 2, then you map on to 49.5 peacefully and nicely. Then 49.5 to 59.5 is 1. So you trace it here, then that is it. This is what we mean by what? Histogram. This is what we mean by histogram. And this was helped with the data we gathered here. So we move on to the next stage. We move on to the next stage. So we move on to frequency polygon. So this is a line graph of class frequency against the midpoint. It can be obtained by connected midpoints of the tops of the rectangles in the histogram. To complete the polygon, the midpoints at each end are joined to the immediate lower or higher midpoint at 0 frequency. Now, we have a question we would have to solve for you to get the concept of it. Draw a histogram for the following data. Draw a histogram for the following data. So the following data, the data is below. So with the age point, it starts from 1, moves to 2, 3, 4, and 5. Then it maps onto 2 as your frequency, then 4, then 2 again, then 5, and 1. So now we are asked to draw a histogram for the following data using the frequency polygon. So now, first of all, you will have to draw your table and find your class boundary. So now, let's draw the table. So now the age midpoint was already given or has already been given to be 1, 2, 3, 4, and 5. Now, we would have to find our class boundary here. So we would have to find our class boundary here. Here we only have what, one figures here. We don't have lower class boundary. We don't have lower class limit or upper class limit. So what you do is that you subtract the first figure from the second one, you get one. And when you do that, you divide it by two. When you divide it by two, you are getting 0. What? 0.5. So you subtract 0.5 from this one. When you subtract 0.5 from 1, you are getting 0.5 itself. Then you add 0.5 to the 1 again, you are getting 1.5. You are getting 1.5. You do the same for the others. So it follows like this, then like that. This is how it is done. And the frequency has already been what stated. So now this information is going to aid us draw our frequency polygon. So now you will have to get your what? You have to get your straight line and your down line. So you first state your frequencies here, and you state your class midpoints down here, or your age midpoint, sorry. So the age midpoint starts from 1, then 2, 3, 4, 5. Then the frequencies, that is 1, 2, 3, 4, and 5. So now, with the age midpoint, so now we are about to draw our blocks. So now with the blocks, we are going to use the aid of what? The class boundary. So with the class boundary, it starts from what? 0.5 to 1.5. So locate 0.5 here. And 0.5 to 1.5 maps onto what? On the frequency, maps onto 2. So 0.5 to 1.5 here. Then I'll move from 1.5 to 2.5. 1.5 to 2.5 maps onto 4. So 1.5 maps onto 4. Then we settle at 2.5. So now 2.5 to 3.5 maps onto 2. So 2.5 maps onto 2. Then we settle at 3.5. Then now 3.5 to 4.5 maps onto 5. So 3.5 maps onto 5. And we settle at 4.5. Then now 4.5 to 5.5 maps onto 1. So 4.5 maps onto 1. Then settle at 5.5. So now this is the block. So now we are about to draw the frequency polygon itself. And as the definition stated, it says this is a line graph of class frequency against the midpoint. It can be obtained by connected midpoints of the tops of the rectangles in the histogram. To complete the polygon, the midpoints at each end are joined to the immediate lower or higher midpoint at zero frequency. So what this is trying to tell you is that now we are going to use the midpoint, the age midpoint itself. We are going to use the age midpoint itself. So now when we have the age midpoint, which is 1 here, so now we map on 1 here, then we map on 2 here, then we map on 3, here. Then it's followed by what? 4. Then finally followed by what? 5. So with these ones, when plotting the frequency polygon, we use that of what? The age midpoint, which is the 1, 2, 3, 4, and 5. But when plotting the blocks, we use the class boundary. So now we are done plotting. So now you mark it 1, 2. Now, so now what we have here is the frequency polygon. Is the frequency polygon. We have the frequency polygon here. So now let's move on to the next. We move on to the next chapter, which is the cumulative frequency. So now we move on to cumulative frequency. So now it says the cumulative frequency corresponding to a class is the sum of frequencies of that class and of all classes preceding that class. Sorry. A. A table showing cumulative frequency is called the cumulative frequency table. B. A graph of cumulative frequency against the corresponding variable is called the cumulative frequency curve or OGIF. Colon. Unless otherwise stated, a question will normally refer to the less than OGIF. Less than OGIFs are drawn using the higher class boundaries. More than OGIFs are drawn using the lower class boundaries. So now there's an example here that's going to make us understand what we are talking about. Draw the OGIFs for the following distribution of marks obtained. And as we said, the cumulative frequency curve is also known as the what? OGIF. So it says draw the OGIFs for the following distribution of marks obtained by 59 students. So of marks obtained by 59 students. 59 students. So we have the table here. So now we have this data here, and this data is going to aid us draw our cumulative frequency. Draw our cumulative frequency. So we are going to draw our cumulative frequency here, starting with our max. Then we proceed to our frequency. Then to our less than cumulative frequency. Then to our more than cumulative frequency. Now, I remember vividly that I explained the less than cumulative frequency and the more than cumulative frequency. With the less than cumulative frequency, you start from the apex, you start from the top, and with the more than cumulative, you start from the bottom. So now let's take our max. So with the max, we have 0.0 to 9, 10 to 20, 21 to 30, 31 to 40, 41 to 50, then 51 to 60, then finally 61 to 70. And let's state our frequency respectively. We have 4, we have 8, we have 11, we have 15, we have 12, we have 6, and we have 3. So now what then do? We would have to calculate our less than cumulative what? Frequency. So as I said, with the less than cumulative frequency, you take your 4, which is constant, and now you add the 4 to the 8 here, getting what? 12. When you get your 12, you add the 12 to the next figure on your frequency what? on your frequency side. So the next figure here is what is 11. When you add 11 to 12, you are getting what? 23. And now you add the 23 to the 15, getting what? 38. You add the 38 to the 12, getting what? 50. You add the 50 to the 6 here, you are getting 56. And when you add the 56 to the 3, you are getting what? 59. So now let's do same for the more than cumulative frequency, but we are starting from what? The bottom. So now the 3 here become what? Constant. So now you add the 3 here towards the 6, making what? 9. And now you add the 9 to the 12, making what? 21. You add the 21 to the 15 here, making what? 36. You add the 36 to the 11 here, making what? 47. You add the 47 to the 8 here, making what? 55. You add the 55 to the 4, making what? 59. Making 59. So now this is how the cumulative frequency is done. This is how the cumulative frequency is done. We move on to the next subtopic. We move on to the next subtopic. So now we are done with the cumulative frequency, we are done with the frequency polygon, and we are done with the histogram. So now we move on to the next subtopic, which is the exploratory data analysis, also known as the stem and leaf display. So under the exploratory data analysis, we are going to do the stem and leaf display. And as you are aware, primary with this stem and leaf, JHS with this stem and leaf. So the techniques of exploratory data analysis consist of simple arithmetic and easy to draw graphs that can be used to summarize data quickly. One technique, referred to as a stem and leaf display, can be used to show both the rank order and shape of a data set simultaneously. To develop a stem and leaf display, 1. These are the steps. So 1, we first arrange the leading digits of each data value to the left of a vertical line. 2, to the right of the vertical line. 3, we record the last digit for each data value as we pass through the observations in the order they were recorded. And 4, the last digit for each data value is placed on the line corresponding to its first digit. I repeat, with the first step, we first arrange the leading digits of each data value to the left of a vertical line. 2, to the right of the vertical line. 3, we record the last digit for each data value as we pass through the observations in the order they were recorded. 4, the last digit for each data value is placed on the line corresponding to its first digit. So now let's solve an example that is going to make us understand these steps. So now let's use these as an example. These are number of questions answered correctly on an aptitude test. So now we are going to draw stem and leaf. We are going to have our stem and leaf display for this. So first of all, you state your stem, excuse me, you state your stem, then your leaf here. So now what we are going to do is that you look at the figures here and you take the first um, digits of the figures here. So for example, we have 10. So we have 10, 12, 15, and 19, and these begin with 1. So you take 1, and we have 20s here. So now the 20s too, you take 2. Then we have 39 here, so you take 3. We have 47 here, so you take 4. We have 58 here, you take 5. We have 69, you take 6. We have 71, you take 7. We have 82, we take 8. We have 93, we take 9. Then we have 108. So that means that it's in the 100, so you take 10. Good. So now for the leaf, when we take 1, we have 10 here, which ends with what? 0. So you write your 0. Then we have 12 here, so 2. We have 15, which is 5 at the end. We have what, 19, so 9. Now we move on to the 20s. We have 22, so 2 here. We have 24, so 4. We have 28, 8 here. And we have 29, and we have, which is 9. Now let's take 30, 30s. So we have 39, which is ending with 9. So we write the 9 here. We move on to the what, 47, which is ending with what, 7. And that's the only 40s here. We move on to 50s, which we have 58. So you write the 8 here since the 5 is already here. We move on to the 69. You write 9. Then it follows. So 71, you write 1 here. You have your 82. You write 2 here. You have 93, you write your 3 here nicely. And you have 108, so you write your 8 here. So now this is how it is done. And when it's done this way, you can use this to find your mean, your median, your mode, and others. So when we get to the next chapter, when we get to the next topic, we are going to show you how to use this to find the median, the mean, and how to calculate for all the other key terms, which is the mean, the mode, the median, and others. So my name is Jima Ades Samuel, known